And welcome to our next video in the EMS Peers EKG Crash Course. In this video we're going to talk about junctional rhythms. Even though I say this every time, I swear this one won't be as long. There's not a whole lot to cover in junctional rhythms, and it's a pretty simple concept once we get the basics down of junctional rhythms. So let's jump right into it. So this is what we're going to talk about in this video. We're going to talk about junctional characteristics and retrograde conduction, and then our rhythms are junctional escape, accelerated junctional, and junctional tachycardia, and then we'll talk about premature junctional complex, or PJC, which is the same as a PAC that we discussed in atrial rhythms. So it's not really a rhythm of its own, but it's a ectopic beat basically. So junctional characteristics and retrograde conduction. So the biggest thing, P-wave morphology and QRS complex morphology. So we'll start with P-wave morphology. With junctional rhythms, the P-wave will always, if it's visible, I'll draw it on the bottom here, there will always be a negative deflection like that. So all P waves will be negative, and I'll explain why in a second here. So as far as QRS morphology, that shouldn't be any different. It should be within a normal range, so not wide, and I'll explain that too. And then regularity, junctional rhythms tend to be pretty regular rhythms, so you shouldn't see anything irregular with junctional rhythms. And then the biggest thing, once you determine those things, you determine you have either no P waves or negative P waves. QRS is normal in width, and it's a regular rhythm. Then all you need to do to figure out what type of junctional rhythm it is look at the rate, and that'll tell you. That's all you need to know for that. So retrograde conduction, I'll draw it over here on the right. It's a little hard. Alright, so with retrograde conduction, what happens is basically with junctional rhythms, the impulse is firing somewhere in the AB junction. So this right here is the AB node, and then the bundle of His. So basically anywhere AB node or bundle of His is the AB junction. And so what happens is the pacemaker is in the AV junction, so somewhere in there is firing and initiating the beat. But since that is lower than the atria or the SA node, the heart still needs to beat everywhere, so the impulse still needs to go up and through the atria, but it's starting lower. So what that does, if we remember the right arm lead being negative, and the left leg being positive. So the vector or direction of electricity is normally in a that way direction, in lead 2 that is. Well, no matter what, it's in that direction, but in lead 2, that's what causes those nice upright round P waves like this. But since the impulse is starting down here in the AV junction, it still needs to come up to the atria. So when the impulse fires this way, it'll just travel its normal path down the ventricles like that up through the Purkinje fibers, but it also needs to go backwards or retro. If you think of retro meaning in the past or behind us, that's what retrograde conduction is. It's in the past, or it's behind us basically, or in this case above. So retrograde conduction will then come up this way in a backwards fashion and depolarize the atria. So that's what causes our negative P waves, because again, with the right arm being negative and the left leg being positive, that means the impulse is going away from a positive electrode towards a negative one. So that causes a negative deflection like this. Now, the reason that the QRS is within normal width is because it's traveling, the impulse is traveling its normal direction. So if it starts right here, it just continues down and then up like that. So there's nothing going on with the ventricles that would cause it to take longer for them to depolarize. It's going to be the same. It's only that it might take longer for the atria to depolarize because it has to go up and through the AV node, which has those interwoven fibers, so that slows it down. But once it gets up here, it'll go the same speed as normal, so it won't really affect the P wave. What it can do is it can affect the PR interval, and I might explain that in a later slide, so if I do, then we'll just skip over when we get to it. But so when that impulse fires right here, depending on where it is, that's what makes the P wave come either during the QRS. So if it's perfectly equal in distance, or the amount of time that it takes for the impulse to get through the bundle of His and down and up into the ventricles and to get through the atria, that means they happen simultaneously. So it doesn't mean there isn't atrial depolarization. There is. It's just it's happening. Blue dog's chewing on her bone. It just happens at the same time that the ventricles depolarize. So the P wave is kind of lost within the QRS and we don't see it. Or it might go down to the ventricles quicker and take longer because it has to go through the AV node to get up to the atria, and that'll cause the P wave to come after the QRS. And then if it is before, like if it's right here at the very tip of the AV node, so it can get out quickly, then it might be before the QRS, but in that case we'll have a really short PR interval. So the whole cardiac cycle will look like this. You'll have a P wave, then QRS like that. So it's like right up against it instead of being like that. So you'll have a short PR interval if it's before the QRS. And then the P wave might be lost in the QRS, and therefore it'll look like there isn't one. Or you might see a P wave after the QRS. It all just depends on where in the AV junction the impulse is coming from. Alright, so our first rhythm is junctional escape rhythm. So a junctional escape rhythm is going to be at a rate of 40 to 60 beats per minute. And it'll have all those other same characteristics. So it's going to be very regular. We're going to have either no P waves, or it'll be a short PR interval, or it'll be after the QRS. So if we go through our steps, starting with regularity, check R waves for regularity. Those do look regular. So next we would check our rate, which going from this one, and since it's regular, we can use the dark line method. So it's 300, 150, 100, 75, 60, 50, 40. So our heart rate is 40. Alright, and P waves. At first glance, it might actually look like there aren't any P waves in here, but there actually are. Let me see if I can draw. It's really hard. Excuse me. It's really hard to see, but there's like a little notch right there, and that's actually part of the P wave. So the P waves in this are actually right there. So there is a Q wave in here, but there's also a P wave kind of on top of it. So it's making it morph into this one type wave thing. So our P waves are like right there, and they are inverted. But even if we didn't see them and we looked at this rhythm and thought there weren't any, it doesn't matter because it'll still bring us to the same conclusion. So P waves are either we don't see them or we do realize that they're there and they're inverted. We have a rate of 40. It is regular. So next thing, we're going to check our intervals. So our PR interval would be about, maybe 0.08, but maybe even 0.04. Yeah, we'll say 0.08. It's about right. So that's a short PR, because if we remember, normal PR intervals are going to be 0.12 to 0.20 seconds. So that's a short PR interval. So our QRS then, I'll erase these P wave drawing things. So if we look at our QRS, it's about, so it looks like it's wide because again we have that P wave kind of coming in where the Q wave is, so it makes it a little weirder and wider. But really, well, I guess it's not too bad. And remember, we're checking, let's see, yeah, it's, so it does look a little bit wide, but it's actually, it's not really, it's just borderline. So like this one goes to there, or from there to there. So that's about like 3-ish boxes, which is 0.12 seconds. So that is like borderline of wide QRS, because a normal one being 0.12 or less. It's borderline, but it is still normal. So QRS is normal, and that's all good. So with that, we can now name our rhythm. So again, it is regular. We have a rate of 40. We have inverted P waves, or no P waves if you don't see them. Our PR interval is short, and our QRS is normal. That tells us this is a junctional rhythm. So all we need to do to figure out what type is look at the rate again, which is 40. So that tells us this is a junctional escape rhythm. And here's the dynamic cardiology for that. So nothing too crazy there. Alright, so accelerated junctional, it's going to be the exact same as junctional escape, everything. The only difference is the rate, which will be 60 to 100. So we'll go through it kind of quick just because we already know what we're looking for. So RR intervals, pretty regular, so that tells us this is a regular rhythm. So I'll write that up here. Regular. So we can use the dark line method. We'll use this one. So our rate is 300, 150, 175. So it's probably like around 80-ish. So we'll just say 80 just because. So around 80 P waves. So we do have P waves. That is what these are right here. So this rhythm doesn't appear to have any Q waves, so those are actually just inverted P waves, because we have a little bit of a, we have that same notch and then a little bit of a area right there and right there. So that tells us that these are P waves and not Q waves, because it shouldn't come back up and flatten down, even though it's very short. It shouldn't do that if it's a Q wave, so that means these are P waves. So P waves are inverted. Just say P inverted. Our intervals, let's see, let's go on the fourth one here. So from right there to right about there-ish, that's also about, put it up here, PRI. So that's also about 0.08 seconds, about 0.08. And our QRS, we'll check on the, I guess the same one. Oh no, let's actually check on the one next to that, the fifth one. So from there there, that's also about 0.08. So that's normal. So now, with all that information, we have a regular rhythm, rate is about 80, inverted P waves, QRS is normal, PRI is short. That tells us this is probably a junctional rhythm. So then, looking back at the rate is about 80, which tells us this is an accelerated junctional rhythm. And then here's the dynamic cardiology, which I just include in these videos. Sometimes, like with junctional rhythms, it's not super important, like it doesn't tell you anything, but it's good to look at, I guess, and just kind of see what it would look like on a monitor. Alright, junctional tachycardia. Again, exactly the same as every other junctional rhythm. The only difference is the rate is above 100. That is the only difference. So, the RR interval, regular, rate, from there, 300, 150, 100. So this is about 110. P waves, yeah, there might be one like right in there, because I do kind of see that little same notch, but maybe not. It could also be lost in the QRS, but either it's inverted or it's not there, so that should be pointing us in the direction of a junctional rhythm. So then our intervals, if there is a P wave in that Q-ish looking wave, going on the second to last one, from there to there, so that's like maybe 0.04, maybe 0.08 seconds. So short, PR is short. And then our QRS is at about 0.08, I guess. Yeah. So our QRS is normal, PR is short. So based on that, we can name the rhythm. It is regular. Rate is about 110. If there are P waves, they're inverted, or there might not be any that we can see. PR interval is very short, and QRS is normal, so it's a junctional rhythm. And then with the rate being 110, that tells us this is junctional tachycardia. Alright, so premature junctional complex. I don't have a tracing for this because the site I use for these, it doesn't have those, which is weird, but it's exactly the same as a PAC or a premature atrial complex. The only difference is there's going to be an inverted P wave or no P wave. So if we have a normal sinus rhythm like this, and then after this beat we have our PJC, we'll just kind of see something like that, and then it goes back. So, so that one there, you can see that there's a negative P wave right there. And there might not be one visible, in which case you would determine it's a PJC by looking at the QRS width. And if it's within normal, then you could call it a PJC, because if it's a PVC, which we'll talk about in the next video, it's going to be really wide, the QRS. So that's what would tell us that this is a PJC. And that's all there is to premature junctional complexes. So now we're already at the final part. So it's a terrible drawing up there, but again, I couldn't find any pictures on that website of PJCs, so I had to make this one, and it just didn't go well, as you can see. So this top one, right there, we have an ectopic beat, and it was kind of hard to, I was trying to make it so it was like right partway in the T wave, but it ended up looking like a P wave that's in there, or a T wave by itself right there. But the next part over here is what's supposed to be the inverted P wave, but I'll just give that one to you since that's my poor drawing. This is a PJC, otherwise normal sinus. Alright, so for this next one, and don't forget you can pause the video on this part to see if you get it right, come up with the answer yourself, and then play it to see if you are right. So the second one, it looks like we have a regular rate, and we'll count off of here. We've got 300, 150, 100, 75. So just write it up here, 75. Our P waves are, yeah, I think there is one in there. So it's kind of hard to tell. Like there's some weird, like just random wobbliness, which doesn't hold any meaning in this, at least. Excuse me. But it does look like there's inverted P waves in there, because that's a little, it could be a Q wave, but it just, I don't know, it's just the way it's all pointy and weird like that. It's just different than most QRS complexes the Q wave going into the R wave would be. So I'll call it an inverted P wave, but even if not, then we just say there isn't one, and still the same result. So inverted P waves or no P waves. Our intervals would have, it's about 0, maybe 0.08, but I think it's more like 0.04-ish from what my eyes can see, which my eyes aren't great, but somewhere in there, 4 to maybe 8. So it's short. QRS is really narrow, about 0.08 also. So with that, regular rhythm, rate of 75, inverted P waves or possibly no P waves, depending on what you see, regular QRS, and short PR interval. So that tells us with the rate of 75 that this is an accelerated junctional rhythm. Then on this one, regular, rate from there, 300, 150, 100, 75, 60, 50, so a little over 50. It does again, because we have a little notch there that flattens out kind of. That tells us this isn't a Q wave going into an R wave, so these are actually inverted P waves. So we have inverted P waves. Next, our intervals. PR interval, again, 0.08 about. QRS about 0.04. So we have a regular rate, regular rhythm with a rate of about low 50s. We have inverted P waves, and we have a short PR interval with a normal QRS complex. That tells us that this is a junctional rhythm. So going back to our rate of low 50s, that would mean this is a junctional escape rhythm. I don't want to write the whole thing, so I'll just write JE, junctional escape. Alright, the next one, it is regular rate going from right here, 300, 150, 100. P waves, I do not see any in here. So we'll go on to our intervals. We can't get a PR interval because we don't have P waves. QRS is within normal range, about 0.04, just a little over. So with that, regular rhythm, rate is, excuse me, rate is about 110. There are no P waves. QRS is normal. So with the rate of 110, that tells us this is junctional tachycardia.